And Colton Madge, Cardo Canada, Mobility in Unknown Spaces. Ladies and gentlemen, here we go.
Hello, everyone. So my name is Joey DeToro, and I'm on here on behalf of Alto Helix. I'm the VP of Operations there. My background is in aviation background, and I'm going to be talking all about drones today. My experience with drones has been started back in 2019 when the regulations came into effect. I've now been in the aviation industry for almost a decade as a commercial pilot, also as an operations manager representing a commercial operation with Transport Canada. The big thing at Alto Helix is what we really want to prevent is kind of bridge that gap between traditional aviation with helicopters and aircraft and bring our knowledge in and applying that to drone operations. We've seen that the future is definitely within drones, so we're just here to really make sure that when you are flying your drones that you are safe and compliant. So certification is all covered by Transport Canada in the Canadian airspace. As of June 1st, 2019, Transport Canada released their initial regulations. These initial regulations covered two different operations under an advanced structure as well as a basic structure. With the basic structure, that allows you to fly in most places in Canada, as most of our airspace is fairly wide open. But when you do get into some of your more complex airspaces around airports, or if you are around bystanders, you do have to have an advanced certification. Both certifications do require an exam to be written with Transport Canada, and the advanced certification also includes an in-person flight review with a certified Transport Canada RPAS flight reviewer. These regulations here, they cover all drones, 250 grams to 25 grams currently. Anything 249 grams and under are not subject to the regulations at this time. They are asked that you do adhere to the regulations, but there is no certification process, as you do not need a license to fly something of that size there. As I mentioned before, the Transport Canada is an online exam written through the Transport Canada drone portal. This exam here, it's all an open book exam that you can write online, and there is no booking or anything that is required for that there. It's essentially go online, write your exam. After you successfully completed that exam, you would have a basic certification, and then if you wanted to add on your advanced certification, that's when you would have to do an in-person flight review for your advanced. With the certification is there, you are able to fly your drone in very basic structures. There are additional reasons when you would have to apply for additional permits. These additional permits are special flight operation certificates. A special flight operation certificate, or SFOC, would allow you to do many different things with the drones. These are certain things like flying your drone at an advertised event. So for example, this morning, we did a demonstration outside using a LiDAR scanner to make a 3D model of some of the shoreline around here. Because this is considered an advertised event and open to the public, it is a requirement for anyone who wishes to fly a drone in this space here that they do go through and actually apply for that special permit with Transport Canada. Some other stuff there that you would need an SFOC for is if you're flying a drone over 25 kilos, or if you also wanted to fly your drone beyond visual line of sight. Currently, right now in Canada, if you are flying your drone, it always has to be within line of sight of either yourself or one of your crew members. To fly beyond visual line of sight, meaning you have that extended distance where you can operate from a single point and cover more of an area, you would have to go through special planning and permission from Transport Canada. As well, in Canada, you are limited to flying your drone at 400 feet. The reason why they limit your drone to flying at 400 feet above ground level is because traditional aviation is allowed to fly down to, at its lowest point, 500 feet, unless it's for the purposes of takeoff or landing. So with you being at a maximum of 400 feet and their minimum of 500 feet, that gives them a 100-foot buffer between the two different sections of aviation there. So as we talked about there's different categories of drones. The first one there being your micro RPA. RPA, or remotely piloted aircraft, is anything that is under 250 grams. So anything up to 249 grams, you are not subject to the regulations there, but it is asked that you do adhere to them and you are aware of them. You also have the SRPA, or small remotely piloted aircraft. This is something that would fall into the system of 250 grams all the way up to 25 grams. Those drones there are the most traditional drones that you see Most mining applications of those there would be your stockpile management, exploration, any sort of mapping or surveying as well can be done with the drones from above now. As I mentioned before, anything 25 kilos and above, you would be required to have a special flight operations certificate. For the most part, drones are getting either smaller into the micro category, or they are getting much larger to above 25 kilos. The reason for that there is just the way the regulations are with anything 250 grams or less. Most people have now come to the realization that you don't need to go through the certification process. And for anything above 25 kilos is more so when you want your larger payloads, or if you wanted something that is a long-range drone. Some different applications for that there would be your long-range mapping missions, different corridor inspections, and really anything where you wanted to replace an aircraft. Most stuff is being replaced with drones now with the new introduction of SATCOM links. Just with the technology that was previously reserved only for military is now making its way into a public aspect. As mentioned before, as you can see from that diagram there, when you are flying your drone, you have to keep it within visual line of sight. So always being able to see the drone there. Keeping your drone 400 feet and below. Some people may say, well, 400 feet is pretty low. For the most part, the sensors that are available in today's market, you don't need to be any higher than 400 feet. For military applications, I'm sure as many people have seen the different videos with military drones, the sensors they have on there are much greater than what you're actually going to have for civilian use on there. So most drones, when you are doing mapping missions, you're usually somewhere in the range of 100 to 200 feet at most anyways. An SFOC. So an SFOC talked about there, this goes through additional planning on there. So this would be more of your risk assessment. The reason for this here is Transport Canada and different government agencies around the world right now have taken a very cautious approach to drones. Since early in the 2010s, when drones were first coming out into a public market, there have been many regulation changes around the world. Recently, 2019 in Canada, when they came out with their certification process, which was a result of the industry really starting to expand and more people using them, they needed an easy way to track people who were actually flying the drones and an easy way to ensure that everyone was trained. The SFOCs now, for when you want to do something more advanced within your operation, something, for example, of a foreign operator, as they're currently not able to be licensed in Canada, flying at an advertised event, near military airspaces, beyond visual line of sight, having a max takeoff weight above 25 kilos, flying above 400 feet, restricted payloads, something with an explosive payload, or if you were carrying something for transport, or also flying 5 drones at once. I'm sure everyone has seen those drone shows now where you have hundreds of drones flying at once and they make lights up in the air, used for different things, marketing, replacing fireworks and so forth on there. That's when you would have to have your additional planning. And the reason for that there is just because Transport Canada would like to know, just to ensure that your operation is safe and there's no additional risk to the public there. So one of the biggest questions we always get is, should I get a fixed-wing drone versus a quadcopter, and what are the differences between the two? The fixed-wing drones, as you can see there, the black drone, that is an EB. So that is a fixed wing with traditional wings on it versus the quadcopter, which is a multi-rotor or more traditional like a helicopter. The fixed-wing drones are great because they can cover a long distance of time. They can stay up in the air a little bit longer as the wings are actually creating most of the lift, and the engine itself is just a propulsion method. Typically, the fixed wings are for your long-range surveillance. You're also doing long-range mapping missions or any sort of general surveying work. The quadcopters, you're more widely used in your cinematography aspects, photography, as well as inspections. The big benefit between a quadcopter versus a fixed wing is the quadcopter can actually sit and hover and look at different objects on there, versus with the fixed wing, because it has the engine for propulsion and it's not like a helicopter, it does always have to be moving, so it does make things a little bit more difficult. For the future, we see a lot of the stuff moving towards the fixed wing market. The quadcopters, as great as they are right now, the fixed wing market is definitely the future for drone operations, being able to actually go out there and replace airplanes for different service work versus the quadcopter. It's great to throw up and take your picture, but for any larger scale missions, the fixed wing is definitely the way to go on there. Fixed wing drones, now we're starting to see them coming out. with different applications for them, even with solar drones. So solar drones can stay up there indefinitely as long as they're in sun. The drone will be able to stay up there versus the quadcopter. Obviously, you're limited to how long your battery power actually lasts for on there. In terms of payloads, so payloads has been one of the biggest things that we've seen in recent years of different manufacturers coming out with very specific payloads for applications. As you can see in the top left there, that is a LiDAR scanner. So a LiDAR scanner giving you your 3D modeling and actually shooting at lasers as you go. This is great for a couple different applications on there. One of them being if you were doing a terrain model, being able to remove different layers as the lasers are actually able to shoot through foliage, going around stuff through there. And many scanners now you can actually pair with drones as well as ground-based. So to do a complete 3D model, for example, you could take a mobile handheld LiDAR scanner, actually walk through the interior of a building, create that 3D model, and then also put it on the drone and do an outer scan as well. And then you can mesh those two files together and actually have a complete 3D rendering of the inside and outside of a building. Some other applications on there, as you can see, are the aerial spraying. So the aerial spraying is becoming very popular now as well to disperse chemicals, to water your crops. Instead of having to bring in helicopters or crop dusting airplanes, people are now able to use them with drones here in more remote areas. There's also various life-saving missions that we're seeing a lot of the first responders using now as well. So with drop payloads, they're being able to go use them in a search and rescue application, find what they're looking for, and be able to drop in life-saving equipment to them. There's been many case studies done around the world as well for dropping certain things for medical supplies with COVID vaccinations, especially instead of having to send a helicopter now for a smaller payload or delivery, they're able to just use the drones. As you can see in that bottom center picture there, there's also a large assortment of different payloads that can actually be attached on at once. Something like a speaker or a spotlight, a thermal camera, an optical camera. All that sort of stuff there is definitely becoming more and more popular within the drone industry. And then, of course, as everyone knows, drone delivery is going to be the newest, greatest thing in the coming years here. It seems everyone around the world is pushing for that there, and everyone is going through different testing stages right now. In Canada, we are actually lucky enough to have airspace and a governing body that is able to see the future on there, and you're actually able to do testing in northern Canada. So a company like Drone Delivery Canada, who is doing extensive testing right now throughout northern parts of Canada, delivering to remote communities for various applications. Something like Amazon as well, or Canada Post, where they're going to be able to deliver objects or parcels to you right as soon as you need them there. For the most part, in your mining applications, though, you are going to be using the drones with either a LiDAR payload on there for laser scanning or an optical sensor for photogrammetry. Photogrammetry being able to go up there and take hundreds of pictures and stitch them all together to make them into a large-scale image on there. A lot of people ask, what's the future of drones? Right now, the biggest issue with the drones is there's a lot of public mistrust. People don't really know what the drones can do other than that they can fly. There's a lot of infrastructure that's not yet quite in place for the drones to actually get to the level where they would like to be. Something where there's a system similar to the traditional aviation system for air traffic control. How are we going to be able to track all these drones while they're up flying in the air together? How are we going to make sure that they're able to avoid other aircraft up in the air? There's been various studies going on around in the world right now with different tracking systems for drones. Most recently, NASA has actually changed Reno, Nevada into a smart city where they have created RFID tags and tapped into the 5G network. By tapping into the 5G network, they're able to track drones live as they're flying around, seeing who the actual operator is, where they took off from, what type of drone it is, and all kinds of information that they're actually to be able to get from those tags on there. There's also been custom no-fly zones put up around airports now to increase safety for airports and airplanes when they're coming in to land. There's also been additional security put up around jails, as recently there was issues with drones flying over and dropping packages into jails and stuff for prisoners while they're in there. BVLOS operations as well, before that you're actually able to start doing these BVLOS operations commercially, they need to have infrastructure put in place to be able to have live tracking of these drones and also figuring out how are we going to do this? Are we going to have hundreds of drones flying over top of people? And that's where the FAA comes in right now. They're currently doing type trials for various certification levels of drones. This includes a couple different things for noise abatement procedures. I'm sure you can imagine if you have hundreds of drones flying over top of the city, it'd be quite loud on there. Other things as well, for example, if I have an engine failure with a drone or some sort of emergency, how am I ensuring that the public on the ground and other aircraft airspace users are safe as well? Having registered airspaces as well, so flights into controlled airspace, how are we limiting those risks with other aircraft in that space? Something like a crop duster who's always flying low, or helicopters who are coming in for medevac flights. These are all answers that are, or questions that are being answered right now by various groups around the world, and we're still waiting to see for that first country to really come out and say, all right, we're going to be the first ones to allow different drone operations happening here. In the US, you're probably going to see first for RFID tags. So the remote ID tags are all going to be tapped in again to the 5G network and being able to scan them as they're flying past and relay important information. Once you have an infrastructure like that in place, that's when you can start to commercialize the drone industry. Something like drone delivery, BVLOS for long-range surveillance, and then finally getting to the point where you have your electric VTOLs, or vertical takeoff and landing aircraft, where you can actually have an air taxi service without drivers. As you can start to see around the world, different companies are inking deals now where they're actually able to move 4 people at once through a drone without a pilot. It'll come, it'll pick you up like a regular taxi, take off, fly to a certain area, and then drop you off. I'm sure many of you guys have seen the Jetsons before, and that is the vision for a lot of companies of where they think things are going right now. Currently, right now, you have a lot of private companies in Canada working up in the north, doing various research projects and seeing how this technology can be applied in various ways. At Alto Helix, for the past 2 years, we've been working with Transport Canada to actually test beyond visual line of sight, how it works with different consumer-level drones versus military applications. And so far, we have seen promising results on there, to the point where Transport Canada is now actually starting to get ready to move forward to make BVLOS, or beyond visual line of sight flights, more readily available to a lot of companies. The future of drones, we can definitely see there are really going to be the future for a lot of stuff in various applications. Right now, the most popular one that we have is inspections and also doing photogrammetry to do different site planning and stuff like that there. But as more things are becoming virtual, being able to actually have drones going out there and being fully autonomous, being able to go capture data on their own repetitively with the exact same data so you are able to compare the data sets to each other has been one of the most invaluable time-saving things that have come out from the drone industry. And especially now with many manufacturers that are creating payloads especially for drones. For example, when LiDAR was first created, it was about the size of a fridge. You needed a helicopter to actually go out there and fly it. Now they've actually cut it down into something as small as up to a pound and a half. It's able to go directly on the drone. Anyone's actually able to go out there and fly it, and then you can render the data without having to have a helicopter brought in for a day, just with your cost reductions on there. So I just want to thank you guys for your time today, just to quickly go through all the drone regulations and kind of what the future of drones are in Canada and around the world. I hope it kind of gives you guys a bit of an idea of what the drones are able to do as well in a mining application. This time I'm just going to turn over to you guys if anyone has any specific questions about drones, their payloads, or anything with regards to the regulations. Yeah. So I was actually up in Moosonee a couple weeks ago and speaking to them about that project there. So they are slowly moving forward. They're just looking to kind of finalize how it's going to be done. So right now up there, they're spending about $5,000 or $6,000 for every time they need to fly a helicopter for just something as simple as flying medication across the river. So they have been in pretty advanced talks to actually open up on both sides of the river. They're having a drone landing zone on one side, being able to load it up from one side of the river, fly it, I believe it was about 19 kilometers, and then fly the medication and necessary supplies across the river there just to cut down their costs as well as time to get everything organized on there. So that is one of the biggest benefits of drones there. It's happening all around the world, in Africa, many remote parts of the world. like that there, where the infrastructure isn't necessarily in place to have aircraft and helicopters regularly flying in and out with passenger service. The drones are definitely a great alternative to replace that there.
Just one more on that topic. For that particular drone, the existing drones, I mean, I learned a lot about how you're developing the technology, infrastructure, regulatory platform. At this time, say you're flying something from those 3 years back, how big a package can we do?
So that all depends on what the actual drone is certified to fly for. So there are drones that are doing delivery demonstrations right now where you have up to 150, 200 kilo payloads on them. So some of them are just essentially a helicopter where they've removed the pilots out of them, they've put in a computer in there, and they're able to remotely control them from anywhere around the world via SATCOM. So the payloads have definitely gotten there. It's no longer where you're looking at your pound or 1 or 2 pound payloads anymore. You are able to use these commercially for larger scale deliveries. So. Any other questions there? All right.
Thank you very much. That was
Thank
really
you.
informative.
Thank you.
It was really great.